All right, so our last example for Chapter 7 and for Section 7.5, we're going to look at one more case where we're comparing the difference between two population proportions in a confidence interval. So in August 2014, random samples of 2,002 Americans, non-scientists, and 3,748 scientists were asked if the space station had been a good investment for the United States. Of the non-scientists polled, 64% said that it had been a good investment. Of the scientists polled, 68% said that it had been a good investment. Construct a 95% confidence interval for the difference between the proportions. Based on your confidence interval, is there a difference in the population proportions? Explain. All right, so again, it doesn't really matter what we pick for population 1 or population 2 as long as we stay consistent. I am going to set this up where N1, our first population, is going to be all American non-scientists. Right. So then population 2 is going to be all American scientists. All right, so let's fill in our information for non-scientists first. We are told that there was a sample of 2,002. So there are 2,002 non-scientists sampled. And then our proportion for that of the non-scientists polled, 64% said that it had been a good investment. So this is going to be 0.64. Right, for the scientists, there were 3,748 were sampled. Of those, 68% said yes. So our P2 hat is 0.68. Our confidence level we're told to use is 95%. Right, and what we're looking for, what we want to know, the confidence interval, P1 hat minus P2 hat plus or minus M. And then again, we're going to ask the same question that we looked at in the last few examples. Is 0 included in our interval, or are they both positive, making P1 greater than P2, or are they both negative, meaning that P1 is less than P2? All right, so first we're going to check our conditions for our population 1 being our American non-scientists. Okay. So the sample is random and independent. Yes, we're going to assume that that is true. Right, and then we'll go ahead and label this. This one we're thinking non-scientists. Population 2, we are thinking scientists. Right, so N1 is 2,002 people. P1 is 64. So at least 10 successes and 10 failures. So 2,002 times 0.64, that gives us 1,281, which is large enough. 2,000 times 1 minus 0.64 gives us 721, which is also large enough. Again, remember that this number that we get for our successes is our X1 that we're going to use in StatCrunch, and our N1 was that original 2,002 people that were sampled. A large population, all non-scientists. Greater than or equal to 2,002 times 10. We get 20,020. That works. All right, now we're going to check our second population. Sample is random and independent. Again, we're going to assume that that's true unless we're told otherwise. At least 10 successes and 10 failures. Our N2, if we go back up to the top, is 3,748. Our P2 is 0.68. So we are going to take 3,748 times 0.68, we get 2549. If we take 3, which is large enough, 3748 times 1 minus 0.68, we get 1199. Also much larger than 10. Again, remember this number here, this number of successes is going to be our x2 that goes with our n2 of the 3,748. Right, all scientists greater than or equal to 10 times 3,748. Right. Pretty safe assumption that there's more than 37,480 scientists in the United States. All right, so now we're going to plug this information into StatCrunch. Right, so again, the information that we're going to end up using is the stuff that's in green, our N1, our N2, our X1, our X2, and then we're going to use that to get a result. And what do we get? Our confidence interval that we get, negative 0.066 to negative 0.014. Right? So, looking at this then, notice that 0 is not included in our interval. Right? So we're not going to say that they could be the same. Again, we're going to go back to that table way back on page 32 of the section 7.5 notes. Both values are negative, so P1 is less than P2. So that's going to be our conclusion. So we're going to write out a couple of different sentences. So right underneath here, I'm going to say the confidence interval, the CI, does not include 0. So there is a difference. And then we're going to say, since both values are negative, P1 is less than P2. All right, so I'm kind of squeezing all of this in very tiny here down at the bottom. All right, so our interpretation. Okay. The proportion of non-scientists who believe it has been a good investment is less than the proportion of scientists. Right, because P1 was our proportion of non-scientists. It was less than P2. So our proportion of non-scientists who believe it has been a good investment is less than P2, which is our proportion of scientists. The plausible difference is between 1.4% and 6.2%. So our proportion of non-scientists who believe it has been a good investment is less than the proportion of scientists. The plausible difference is the percentages that we see here between 1.4% and 6.2%. Right, so then that wraps up our confidence intervals for two proportions for section 7.5 and the entirety of chapter 7.